Welcome to this video on automated security testing. In this video I'm going to look at automated testing to identify potential security issues in software. This is part of my series of videos on threat analysis and risk mitigation and part of a practical example of securing my Raspberry Pi Pixel server ready for connecting to the internet. Whilst this is about cybersecurity testing, really that's just one aspect of the testing, and the methodology explained will test functional, operational, as well as some of the coding strategies as well. I'm just going to look at it in terms of a web application running on the internet. The particular testing I'll be looking at here is application testing. Later in the video I'll be looking at the specific tests associated with application security testing. This shows the kind of testing I'll be looking at in this video. These are tests running in Pytest-3. They're testing various components of the system. There are several different tests running and they are automated through Pytest. Some of the tests are defined manually, manual automatic tests, and some are automatically generated automatic tests. I won't go much into the reason for needing tests. Hopefully it's fairly obvious that you want to identify bugs before attackers do. But you may also want to look at my other video on why testing can be a good way to develop software. See the link on why testing is fun in the description. I will, however, mention the concept of regression testing. One of the main advantages of automating the testing is to identify if any changes to the code break something that was working before. This can be important from a security point of view if code is written making assumptions about what checks other parts of the code performs. There are different ways to test a system and different kinds of tests. But for the purpose of this, I'm going to split them into three methods. Really, this is just to give an idea of the context for this testing. In this case, specifically looking at a web-based application and testing the web interface. Other systems may be very different in their testing requirements. I'm concentrating on automated testing here, the distinction being that automated tests are run by a tool rather than a person manually running each of the tests. But there will be a different level of automation, as you'll see later. The first is manual testing. This is an essential part of any software development. It involves interacting with the system as a normal user would and can involve testing on different devices. It is intuitive from the tester's perspective, but due to its manual nature, it is very intensive in terms of human involvement. Effectively, very expensive, and it's difficult to get a good range of testing. As well as the ad hoc testing during development, this is often used for more structured testing strategies, including user acceptance testing and operational readiness testing. I won't be going to that here, but developing a web application will always involve some kind of testing from an end user's device. Next I'm going to mention is using an external tester, which could be automated browsing and fuzz testing, or known as fuzzing. This involves having a program specifically designed for testing which will run automated tests as a normal user. These can be manual tests or automated, and in the case of fuzzing, that is about automatically trying lots and lots of different combinations of edge cases or invalid data to identify ones that may break the system. There are some open source tools that can help with these, but a lot of the tools available are cloud-based systems. The tests I'm going to be looking at in this video I've called application testing. This is testing the application during the development of the software. This incorporates different types of tests, including unit tests, functional tests, and regression testing. It typically runs on the same system that you are developing on and includes tests that developers can run regularly when developing the software. These are often based on the particular programming language that's used for developing the software, in this case using Python. I've listed two frameworks here, Pytest and unittest. I used unittest in the video I mentioned earlier, but used Pytest, and in particular Pytest-3 in this video because of its integration with Python Flask, which is used as part of the web application. Here is an example of one of the tests that will be performed. This is known as a unit test, as it tests a particular unit of the code. I'll be explaining more about the different types soon. In this case, it's testing the server user class. It creates an instance of the server user class with some values, then checks that those values are set correctly. This is done using the assert keyword, which tests that that particular condition is met. As you can see here, there's multiple assert keywords, so there's multiple tests performed within this particular test. So for example, this sets the first parameter, which is the username, to the string username. Then it tests to ensure that that is indeed set to username. It does the same with the password hash, which is tested here. And this is using an argon2 hash password. And then it does that with the rest of the values as well. So let's see some tests in action. So here I'm going to use Pytest-3, and it's going to automatically look for all the tests that are on this system, which is going to include this one, but also others as well. It looks in the test directory, and then based on the file name and then the name of the functions, it can determine which of these are the tests. It runs all the tests and just gives information on whether the tests were successful or not. Here it shows dots for each of the tests run, and then in the end 100% success for all the tests being passed. All the console information is suppressed, so you can just see when the tests work. If you wanted to see the console output, then you can use the -s option, and then if you use any print statements, they'll be shown. But I'll show an example of what happens when a test fails. So that particular test, I've just created a separate folder under the test directory called video1, and that's the test under there. So I'm going to change that. I'm just going to use the vi editor. You can use whatever editor you want, and what we're going to do is set the username to a different entry, so user1. But I haven't changed the assert statement, which is here, which is still looking for username. So this should create a user called user1, or username user1, and then when it does the test, then that's going to fail. Now if I run the tests again, you see all the other tests still work correctly, and it will only be when we get down to the particular test I've been editing that you can see it's failed. I'll just scroll back up here so you can see a bit more. So this is the overall view, and you can see that instead of having a dot, it shows F to say it's failed. It's run 100% of the tests, but the last one failed is what this is saying, which is explained in the summary here. 1 failed, 65 passed. And then it gives you some information about the code. It's showing the particular function that we created and saying that this assert line failed. So we can go back in, we can change this to user1. So now we're making sure that we're setting the user to user1, and we're making sure it is indeed set to user1. And now if we run the test again, this will now pass 100% now. And there we go. So that shows you what would happen when you have a failed test versus a successful test. The example I've just shown is known as a unit test, but I'm also going to cover functional tests. Unit tests is testing individual components of the system, essentially the functioning of the different Python classes that have been created. Functional tests test the functionality of the system and whether it performs as expected. From that, you may be expecting that if you have good functional tests, then you don't need to worry about unit tests, as you've already tested the functionality. I find that using both can help pick up things that the other testing mechanisms may miss. This also helps with the aspect of security in depth or layered security. You may have heard of terms such as black box and white box testing. The unit tests are usually white box tests in that you need to understand how the code needs to be called to create the tests. The functional testing can be black box, which assumes that you don't know the code, or can be influenced by the way the code is written, white box style. When creating functional tests, whilst I do know the inside working of the code, I like to start by taking a black box approach. I work through the steps from the point of view of how the user would interact with the system, essentially using the user story from the agile development approach and turning that into a functional test. I may then add more tests based on my own view of what should happen, which is influenced more by the white box style. There's other types of testing, such as non-functional testing, which is about testing customer expectations rather than functionality. Things such as performance and response time. These are things that you may need to consider from a security perspective when looking at denial of service attacks and such like, but I won't be explicitly covering those here. There is sometimes a security compromise in non-functional requirements. I made one such decision based on performance versus security with a security hashing algorithm. I've already covered that on my earlier video on triad analysis. See the link in the description for more details about that. I'm going to take a look at another unit test here. One of the things that it's showing here is that you don't need to manually code all the information within the actual test function. In this case, I've created two lists which contain the information on a user. You can plug these into the test. In this case, I'm calling a function. I've used the asterisk character to expand these into the function call. This can make creating the test data easier and allow you to use the same data in multiple tests, which can be useful. The next step is to move the lists or the data into a config file. I'll be showing an example of that later in this video when I look at functional tests. But before I get to that, I'd like to show one more unit test first. So here I'm going to show that in action. I'm going to add additional user and we'll create a test for that and show you that that's simpler than having to recreate the whole thing. So I'll just run the test first. And I'm just going to specifically run this particular one. As you can see, it's passing the test so far and it's got 14 tests. So I'll just edit that. And I'm going to duplicate one of these. And now we can change whatever these details we want to do. And for instance, in this one, I'll leave a couple of blank entries and see if that still works. That should be it. As you can see, we've now got 15 tests and it's tested that additional user, in this case with a blank email address and a blank description, both of which are allowed in this particular circumstance. Before we move on to the functional tests, I'll show one more example of a unit test, this time using random data. The advantage with this is that it can allow you to test lots of different possible values. In this example, it changes the values to different strings to see if any combination causes this to break. I've defined the characters which are allowed and then set it with a number of changes that it's going to implement, and this is how many different combinations it's going to use. You could easily change this to a higher value, which will perform more tests but take longer, or a lower value, which will perform less tests. One of the things I like to do is set a high number whenever you make a large change to the code, but then set it to a lower number for when making smaller changes. One thing to be aware of though is that just because it runs a lot of tests, say 100 tests, does not necessarily mean it's tested various different circumstances. If it only ever generates valid passwords, then that is not the same as testing with an invalid character. This can, however, be a useful test if you want to generate data using more complex rules, or if you want to check that a system is able to handle lots of different entries. You could also set it to create really long passwords to see how the system handles those. So here I'm going to show that function creating some random passwords. I'm going to just edit it a little so it creates a print and shows you the passwords, and so we can see those through the tests. So we'll leave it as 20 password changes at the moment. So this is the function that was shown before. When it creates a new password, I'm just going to add a print statement here so that we can see the password. And normally that would be ignored or would not be shown to the user. So I would add the -s option, which will show the print. As you can see, these are the different passwords that have been created, and these have got various different characters in various different lengths, and in this case they've all been passed, and this is something that you can modify to see how they respond and things like that with various different types of passwords. The tests so far have been unit tests, just testing a small part of the code. But using Pytest, you can also perform functional tests against a test Flask server instance. So this, we're going to use Pytest-3 again, and it has the Flask test client. This is going to increase the amount of code needed, as we need to create an instance of the Flask app and then the test client, and then use that to run the tests. So here's a basic example of what that looks like using Pytest and Flask. Now, this is a very basic test, but it does include additional code allowing for different configuration files and to set up a temporary test directory with its own configuration files. It's not mandatory, but when you reach the functional testing, then the tests are going to involve making changes to a server configuration, including adding new users to the configuration files. So one of the things with this is that you can create a temporary directory and copy the existing config files so that each instance of the test has its own set of configuration files for a fair test. Looking at this code, you can see there are two functions: test setup factory, which makes the call to temp directory setup. These use the temp path factory to create the unique directory for all of the tests in this particular file. The actual test is called test index 1. It creates an instance of the Flask app, and this involves some changes to the Flask code which I had made, but otherwise runs the Flask server using the same code as the actual web application. One decision I did make was to remove the cross-site request forgery module. This was to simplify the automated testing, with the CSRF being tested manually. It then creates a test client which is a feature of Flask specifically for testing and uses the client to perform a test request and check the responses as expected. So here I can run the functional test with Flask. I've already created it in its own directory just to simplify this. As you can see, it looks the same as when running the other tests. It basically runs the test and gives you the confirmation of how many have passed. But behind the scenes, there's a lot more happening. It's running the web application and then using the test client to test against the web application. A functional test similar to how a user may interact with it. When I create functional tests, I often start by looking at the user stories from Agile's development methodology. This is an example of a user story, which is to be able to log in as an admin user. So it starts from accessing as a guest user, and then I want the user to log in as an admin user, and then this should allow them to access admin functions. The test criteria is to ensure they've entered a valid username and password, and that the user is then logged in, and there should be a link to the admin page. From the user story, I've created a simple flow diagram showing the actions and how to check if it's successful. This is what will be implemented in the code as a single test. As you can see from the diamond shapes, I've included questions at multiple stages in the test. These are implemented using the assert keyword. If they pass, then it moves on to the next stage in the test. If any of them fail, then the test will immediately fail. So here's a more complicated test based on that. It uses the same setup code that we used before, but then performs the multi-stage request based on the flow diagram I've just shown. In this case, the user requests the root page, which is then successful. It then requests the /login page, which provides a login prompt. It then uses a post to submit the login information and checks that the user is logged in as an admin by looking for the existence of the admin profile button in the return data. These could be created by following the normal steps that it would take for a user to perform that task. When thinking about security, you also need to think about abnormal routes. For example, what if a guest tries to access a page which should only be available to a logged in user? So I've created some functional tests. This is going to be a bit longer than the one before, but it's in the same file. This has got 11 tests, and as you can see, they've all been passed. So that's performing those kind of tests by pretending it's a user, logging in, making sure it's an admin, and other kinds of tests related to those. For this final example, I'm going to show how you can create data files to make it easier to create test data. I'm going to start with this user story of creating a new user. This assumes the user is already logged in as an admin and then goes through the steps in creating the new user. I've not created a full flow diagram, so that would be too big to show here. Instead, I've listed the main steps. The actual process is longer as the user needs to log in as part of the test and future tests to go on to add more details about the user. I've also added assert tests at each stage, but this gives some of the key steps in this particular test. In this case, the user is added by first entering the username. This allows the system to check it's not a duplicate before it asks for the password and then creates the actual user. There is quite a bit more code involved in this, so I've only shown the relevant parts of the code here. For more details, see my website linked in the description. This test will read in user information from a data file and then attempt to create the users using a functional test. I'm using JSON formatted data here, as that is easy to understand and can be easily used with Python. I've added the line import JSON, which is at the top of the file. In the test setup factory function, I've opened the configuration file and opened it through the JSON load method. I'll come to the actual test in a minute. First, let's look at the JSON file. So here's a JSON file for the test. I've shortened this example to just 2 entries. There's a square bracket covering all the entries, which is to indicate that this is a list of entries. And then the curly braces show that the data for each entry is a dictionary. From the username to the description are the fields that will be used to test that this is successful or unsuccessful creation of the user. I've then added error and error message for the test parameters. So one thing about testing is that a test can be successful even if it gives an error message. In fact, testing for successful handling of errors is one of the main aspects in security testing. If the value of the error is none, then it tests for a successful user creation. If not, then it says where we expect the error to occur. So the second test will fail during the error stage, and if that happens, then that's a successful test. The error message entry is then used to check that we get a correct error. So if it's an expected error and it comes back with invalid character in name, then that's a successful test. This is just the way that I've created these tests. For your own tests, you can put whatever you want in the JSON file. Back to the code, you can see how this works. The for loop iterates over each of the entries in the JSON file, attempting to create the new users in the file. This shows the first stage where it tries to add the username. If the test should fail at this stage due to an invalid username, then it tests for a failure. If it's not, then it tests if it is successful. It then goes through each of the different stages, which include defining the user, setting their password, and editing their user information. But I've not shown that in this video. I'm going to show you the directory structure I've used to create the test directory. Basically, it allows you to create different subdirectories for the tests. In this case, the unit and functional tests, which allows you to run all the tests or just specific tests. So here's the test directory. I'll change into it. And you can see in here I've created a configs and data directory. The config directory is something I use for creating separate configs for different tests. I'll ignore that for now. The data directory has got those JSON tests that we showed earlier. And then there's the 2 directories, functional and unit. So I'll just show the ones I've got at the moment in functional, and then there's ones in unit. To run all the tests, we can just run Pytest-3. And you can see that it's run both these functional and these unit tests. If you just want to run the functional tests, you run Pytest-3 and tests/functional. And it will just look in the functional directory. And you can do the same with the unit tests. Now you could use these completely differently. You could put separate folders for different kinds of tests. But I find it useful to be able to test using this if I'm using a different platform. For example, I often develop for the Raspberry Pi, but because of how it connects to physical components, I find it more convenient to write the code on my computer running Ubuntu. So I can therefore run the unit tests on my computer, but any tests that will only run on the Raspberry Pi, then I can leave those until it's uploaded on the Raspberry Pi and run it there. So far, these tests have been standard application development tests. It can be much about testing the code for general bugs rather than those specific to security. The security aspect is really about the data that's used in the testing and to ensure that the tests can detect potential security vulnerabilities. Here are some examples of the types of data that can be used to perform security testing. Edge cases. These are a part of standard software development. but can be particularly useful for security testing as well. Edge cases are where data is likely to trigger parts of the code that is not used during typical operation. For example, providing an empty string, creating very long entries, using special characters, or other instances which could potentially trigger an error in the software. Policies allow us to check against any security policies we have defined. For example, invalid usernames, which could be because they're too short or they have invalid characters, or invalid passwords, such as if they don't meet the password complexity rules. There may also be certain tests required for compliance, such as ITGC, IT General Controls. I've included these under the policy, as the company security policy should be developed based on any certifications or frameworks that the organisation needs to comply with. You could also test for known threats. These are ones that can normally be identified using the threat analysis stage. For example, if you use an SQL database, then you may want to check by attempting an SQL injection attack, or checking user data to prevent cross-site scripting attacks, preventing a user from adding scripts into submitted data. You may also need to check what happens if a request is out of sequence, such as trying to edit a user before it's created, or unauthorized actions by trying to change a user without the appropriate permission. You could also check for being able to access information that is confidential or a buffer overflow by sending excessive amounts of data. I've put code-specific tests as a further catch-all to make you think about the way the code is designed and is there something specific that you may need to check. For example, when I created a new user, I start by specifying a username and then added the password in the second HTTP post. That post included both the username and the password. But what happens if the user uses an invalid username at the second post, but not the first? There are likely other things that the developer has already included in their code to prevent a security breach, which should be fed into the tests as well. These are just some examples of things you may want to test for. Depending upon your application, there could be many others. But this is where we start to think about security-specific testing. I've taken the approach that it's the developer that's creating the tests, but what about if it's someone other than the developer? Firstly, I'd start by saying that I think the developer creating their own tests is an important part of the testing process. It shouldn't just be left to a third person. But it may also be useful for testing to be performed by a third person. That is someone who is not the developer and not the end user. When I think about third-person testing, this is often different to the application testing which I've covered here. It will often include user acceptance testing or ORT, operational readiness testing, or other testing strategies. And these are normally black box tests, which do not have access to the code. But going back to the application testing, these are normally white box tests where you can view the code. This can be understood through a code review or by discussing with the developer to understand how the code works. An alternative is to start with the existing tests and expand on those, ensuring that appropriate level of code coverage is reached. I've just scratched the surface of testing, but hopefully this has given a brief introduction to allow you to get started with testing, specifically application security testing. There is much more to learn about testing. You may want to look at test-driven development, code coverage, and for security, other testing methods and tools, especially network discovery and testing tools. I hope to cover more of those in the future videos, so if you think that'd be useful, please give this a like and leave a comment so I know what to develop in future. Please also subscribe if you haven't done so already, so that you can find out about the latest videos I create. Thanks for watching. I look forward to seeing you on a future video.